Question number 6. When magnesium is burned in air, it reacts with oxygen to form magnesium oxide. So you've been given your reactants and products here. So magnesium reacts with oxygen, and it's giving you the formula for oxygen, and the product is magnesium oxide. A class of students investigate the relationship between the mass of magnesium burned and the mass of magnesium oxide formed. Each student was given a different mass of clean magnesium to heat. The students used the following method. They weighed a crucible and lid, placed a magnesium ribbon in the crucible, placed the lid and reweighed. Heat the crucible as shown in the diagram until the magnesium burns. Okay, so there's the diagram of it. So then they lift the lid time to time until there's no sign of further reaction. Allow the crucible and lid to cool and reweigh. Repeat the heating and cooling and reweigh until 2 consecutive masses are the same, and calculate the mass of magnesium oxide. So the question is, the answer is to allow the oxygen to come into contact with the magnesium, so that oxygen is all around outside in the air, and when we lift the lid we allow the oxygen to come in and react with the magnesium, as there may not be enough inside in the crucible. Second question is, why is it necessary to repeat heating until 2 consecutive masses are the same? The answer to that is to make sure all the magnesium has reacted. So when all the magnesium has reacted, no matter how much you heat, no more magnesium will react with oxygen because all the magnesium will be gone, and you'll have the same mass of magnesium oxide in 2 consecutive results. Show how the mass of magnesium oxide formed can be calculated from the readings obtained. So if we take the final mass of the crucible and lid that contains the magnesium oxide, then we can subtract the initial mass of just the crucible and lid by itself. That will give us the mass of magnesium oxide equals MgO. Okay, now in the next question we're given some results, and we're asked to plot the results. So you can see we have mass of magnesium in grams, and we have mass of magnesium oxide in grams. So there is this is some continuous data. So this is going to be on a line graph, and you're asked to draw a line of best fit through it. So when we draw a graph, we always go along the corridor and up the stairs. So on the bottom, the mass of magnesium in grams. So the mass of magnesium in grams is on the bottom, and the mass of magnesium oxide is up along the y-axis. So x-axis mass of magnesium in grams, y-axis mass of magnesium oxide. So 0.24. So we'll just go through one with you. So you go along the bottom here, and you see this is 20, this is 40, there's 10 squares in between. So every square is worth 2. So if you go up along, and then you're going to plot 2.4. So you need to move 2 squares over, up, and it needs to be on the 40 line. Now that line's a little bit off, so it would be here. Now this is actually quite small, and it's hard to draw it on the computer. So what I'll do is I'll draw you the results, and you can then interpret it using the mark scheme. So here I've now drawn the put on the points, plotted the points, and put the line of best fit through, so it goes through most of these points here. And then the next question is to identify the anomalous result. So to identify the anomalous result, we circle the one that does not fit the trend, which is here. The next question is, using your graph, to find the mass of magnesium oxide formed when 0.48 grams of magnesium is burned. So along the bottom, find 48, up the dash, up across, and then you get your answer there. Okay, so the answer to that would be 0.82, and the mark scheme says to just assign that based on what the student's graph is. Okay, right, so the marks for the graph were assigned as follows. All points plotted correctly, 1 mark. Second mark, correct straight line of best fit, but does not need to pass through the origin. So that's your second mark. And the final mark was in the second part, was to draw the circle around the anomalous results.